All right, let's do a short little video here on functions and function notation. I've got some examples of function notation up on the board. Function notation is very similar to the explicit notation you're familiar with. I'm just replacing y with f of x. This is read out loud as f of x. This would be g of x and h of x. They're naming three different functions or expressions. F is the name of the function. And x is the variable that function is written in terms of. Our expression for the function, in this case, I've just made up as x squared plus 3x minus 5. F of x is equal to x squared plus 3x minus 5. Function f, written in terms of variable x, is given as the expression x squared plus 3x minus 5. This is typically what you're going to be concerned with most because that's what you're going to use to evaluate the function, your given expression. G of x is another named function. G, written in terms of variable x, function g in terms of variable x, is given as 4 minus x. And for our last example here, just made up h of x is equal to 7. Function h in terms of x is given as 7, for example. Okay. Now, what I've got over here are some different functions and evaluations that we're going to do to each of these functions. Let's practice evaluating functions with these three given functions. I've got a new function for f of x. It's going to be 3x minus 5. When I refer to function f of x, I'm referencing 3x minus 5 for our expression. For function g of x, that's going to be given as 4x squared plus 1. Function g is naming this expression 4x squared plus 1, for example. H of x is now given as negative 2x. Function h of x references this expression, negative 2x. We have different evaluations to find. What is the value of function f when x is negative 2? In other words, plug negative 2 in for x to f, to function f. Plug negative 2 in for x for the function named f. So instead of 3x minus 5, I'm going to substitute 2 in place of x, like I'm plugging in a number to this expression. X tells me where to plug in that number. Instead of x, we're going to substitute in a 2. So 3 times negative 2 minus 5. 3 times negative 2 is negative 6. Negative 6 minus 5 is negative 11. Just like you plug in x to find y, now I'm plugging in negative 2 to get out negative 11. What is the value of function f when x equals negative 2? That's going to be negative 11. Same thing excuse me, for g. Remember, g of x is given as 4x squared plus 1. I want to find the value of function g when x is 3. So let's substitute 3 in for x. Plug in 3 for x to function g. Instead of 4 times x squared plus 1, we're going to replace x with 3. 4 times 3 squared plus 1. That's 4 times 3 squared plus 1. Order of operations, 3 squared first. 3 squared is 9. Then do 4 times 9 to make 36, plus 1 is 7. The value of function g when x is 3 is positive 7. One more to practice. What is the value of function h when x is 0? H is a new function given as negative 2x. I'm going to substitute 0 in for x to this bottom equation, h of x. This notation means plug in 0 for x into function h. Plug in 0 to h for our variable x. So instead of -2 times x, it's -2 times 0, which is just 0. The value of h when x equals 0 is 0. Now we're going to have some different evaluations to do. F of 2a, g of x plus 1, and h of 3x. We're going to substitute an expression instead of a number into our given functions. This notation means the same thing. We're working with function f, so we use 3x minus 5. What do I plug into x for our expression 3x minus 5? I'm going to substitute in 2a, just like I plugged in -2 on this previous example. Replace x with 2a. Inside this quantity, inside this parenthesis, it tells you what to plug in. Plug in 2a. So 3 times 2a minus 5. Three times 2a is 6a. So 6a minus 5. F of 2a is given by the expression 6a minus 5. Once I plugged in 2a for x, for function f of x, I got 6a minus 5. Let's try g of x plus 1. Now we're going to reference function g over here, which is 4x squared plus 1. I'm going to substitute in x plus 1 for x. Plug in x plus 1 to this variable here. G of x plus 1 is going to be 4, but instead of x squared, now it's going to be what I plug in for x, quantity squared. So x plus 1 squared plus 1. I need to take x plus 1 quantity squared. So that's going to be x plus 1 times x plus 1. Expand that out first. So I'll bring down the 4. Take x plus 1 times x plus 1. X times x is x squared. X times 1 is x. Now do 1 times x, that's also x. An x and an x make 2x. 1 times 1 is 1. Bring down the plus 1 on the end. Multiply x plus 1 times x plus 1. That gave me x squared plus 2x plus 1. Now I multiply that times 4. So 4x squared plus 8x plus 4 after I distribute 4 into each of these 3 terms. Don't forget the plus 1 hanging off on the tail end. I can combine 4 and 1 to make 5. So final answer, 4x squared plus 8x plus 5. G of x plus 1 simplified to 4x squared plus 8x plus 5. Now the last one, h of 3x. Let's substitute 3x in for x in our h of x function. Again, h is the name of the function. It's referencing this function h of x over here. 3x is what I'm plugging in to that function. I'm going to plug in 3x for x. So instead of -2 times x, now it's -2 times 3x. -2 times 3x would be -6x. Nothing left to simplify after that. We're all done.